In this video, we're going to review strategies for multiplication. Last year, many of you worked on something called the box strategy. This is also known as breaking a number apart. What you did was you said 46 is really like a 40 and a 6 together, and 8 is just an 8. So you have to make sure that you multiply the 40 to the 8 and the 6 to the 8. You have to share the number to each part. So to help you see this, you drew a box. You showed your 40 here and your 6 here, so that you reminded yourself you needed to do 8 times 40 and 8 times 6. Then we could fill in our answer. So 8 times 6 is 48. And to figure out 8 times 40, we would say 8 times 4 is 32. And then we need to make it 10 times larger, so we get 320. For our final answer, we'd take every part of the box and we'd add them together to get an answer of 368. Another way of showing this is with something called partial products. You're really doing the same thing, but this time we don't need to draw a box. What we do is we start with the 8 on the bottom, that's in our ones place, and we're going to move up to multiply the ones place by the ones place. So I'm going to say, what's 8 times 6? And that is 48. I don't actually have to write it out next to it. I'm going to, just to kind of remind myself of what I'm doing. But 8 times 6 is 48. And then I go to my next column, share the 8 with the 40. 8 times 40 is 320. So see, we have the same parts. We have the 48 from the 8 times 6, just like we had in our box method. And 320 when we did 8 times 40, just like we had in our box method. But with partial products, we don't have to show the number breaking apart because we can use the place value. So it makes it a more efficient strategy. At the end, just like we did with the box, we add our numbers together to get our answer of 368. When we move to the multiplication algorithm, the same thing happens. We're still setting it up the same way we did partial products, and we're going to start with our 8 and go from ones to the ones. So this time I say 6 times 8 is 48. But rather than write down 48 underneath my number, what I'm going to think about is similar to when I use an addition algorithm. If I was adding 16 plus 27, for example, when I say 6 plus 7 is 13, we write our 3 down and carry the 1, which is in our tens place. We're going to do the same thing here with multiplication, so that when I do 8 times 6 is 48, I'm going to write down my 8 and then bring the 4 into my tens place. Now I can move on to my next part of multiplication. So I multiplied 8 times 6 to get the 48, and now I'm going to multiply the 8 times the 40. The great thing with the algorithm is because it's already in the tens place, we can think of it as a 4 instead of a 40. So I'm going to ask myself, what's 8 times 4? Well, 8 times 4 is 32, but I have these 4 other 10s that I carried over that I now need to add. So what I'll do in my head is 32 plus 4, and that gives me 36, and I write it on the same exact line. So if you look at the partial products we had solved before, 8 times 6 was 48. My 48 is right here, and in the algorithm, my 48 is right here. So that's the first part of the problem. And then the next part is the 8 times the 40. So here, 8 times 40 was 320, and on the algorithm, it's a little bit harder to see, but it started right here, and we added the 4. But in the end, you have the same answer. So just like when you're using the addition algorithm, whenever you have a 2-digit number, you're carrying your tens place to the next spot. The same thing works when we're using 2-digit times 2-digit. So just like when you did this last year and you used a box method, you broke apart the 32 into a 30 and a 2, and the 56 was a 50 and a 6. And to multiply these numbers, I have to make sure I share the 30 with the 50 and the 30 with the 6, the 2 with the 50 and the 2 with the 6. So you used a box to make sure you got all of your parts together. So you would go through and say, what's 6 times 2? And fill in that box. 30 times 6, I would think of 3 times 6 is 18 with my 0. 50 times 2 to get 100. And 50 times 30, thinking of 5 times 3 is 15, then multiplying it by 10 and 10 again. And then at the end, you would line up your numbers by place value and add them together to get your total answer in order to solve your problem. We end up with an answer of 1,792. Now we're going to use partial products, or breaking it apart, to answer the same problem, but this time we're not going to draw a box and we don't have to write out every problem we're solving. So we always start, just like with addition or subtraction, with our ones place. I'm going to start with my 6. So for me, I find it helpful to circle the number I'm starting with. My 6 is first going to go up to my 2. So I'm going to say 6 times 2 is 12. But I'm not done sharing my 6 yet, so it's got to go over to the 3. So 6 times 30, because it's in the tens place, is 180. So if you look at what we just did, you'll see my 12 is here, my 12 is over here, there's my 180, and there's my 180. So it's the same exact answers, we're just showing it in a different way. Once I'm done using that 6, I can cross it out if I want to remember that I'm done with it. That's how I know I can move on to my next number on the bottom, which is my 5 or my 50. So I'm first going to go 50 times 2 to get 100, and then go back up to 50 times 30 to get 1,500. Some of you may have remembered this as teachers saying up, over, up. That's another way to remember it. You go up to the 2, up to the 3, and then over to the 2, over to the 3. So that when you're done and you add all your numbers together, you're going to get the same answer. And if you look for all your parts, once again, my 100, 1,500, 1,500. So partial products takes all the pieces that you broke apart before with the box and just shows it in a nice organized list. So when we solved partial products, we went up, 6 times 2 is 12, then over, 6 times 30 is 180, then we went to our 5 and said 50, 50 times 2 is 100, and 50 times 30 is 1,500. And then we added our numbers. Now we're going to take a look at how the multiplication algorithm works. You're following the same exact steps as partial products, but this time, just like when we did a 2-digit times 1-digit, you're not writing everything down. You're going to actually take your tens place and carry it over, and I'll show you what I mean. So I'm going to start the same way, in my ones place, always in my ones place. I'm going to start with my 6, and I'm going to go up and say, what's 6 times 2? And that's 12. But this time, I'm going to write my 2 here and bring my 1 to my tens place. Because if you look over at our partial products, that 1 should be in the tens place. Now I'm going to go over. And think of this as a 3 now instead of a 30, because the algorithm keeps track of place value for me. So 6 times 3 is 18, plus that 1 I add back on at the end, and I'm going to get an answer of 19. So I have 192 when I share the 6 across. If you look over here, when I did 6 times 2 was 12 and 6 times 30 was 180, when I add those two parts up, I get an answer of 192. Before I move on, I'm just going to erase what I carried, so that way it doesn't confuse me for my next step. Now I'm done with my 6, and I'd like to cross it out. So I'm going to move over to where this 5 is. Now my 5 is in my tens place, which means I'm not going to need my ones place anymore when I'm recording my answer below. So what I do is I'm going to put a 0 in my ones place. That means that I don't have to think about place value, but I know that I'm done with my ones place. And that way I can think of that 50 as just a 5. So I'm going to multiply over first. Go to my ones place. 5 times 2, which is 10. So I write down my 0 and bring my 1 to my tens place. Then I go up and say 5 times 3 is 15, plus the 1 I had before gives me an answer of 16. And I just write them right in on that second line. The same way, similar to partial products, where I did 50 times 2 was 100, and 50 times 30 was 1,500. If you add those two steps together, you get 1,600, just like we did in the steps we just took. The great thing about the algorithm is I don't have to worry about keeping track of all these zeros like I do for partial products, because I'm already lining everything up in the correct place value. A good way to check that you're done is I have 2-digit numbers, so I should have 2 lines of numbers. Now, just like with partial products or the box method, the same way to end is by adding them up. And I'm always going to get the same answer.